Welcome to a special episode of 13 Cubed. For the first time on the channel, we're going to have a guest presenter. Andrew Rathbun of Kroll is a name that many of you will recognize. He's authored numerous forensic articles, given presentations at SANS events, he's a frequent contributor to AboutDFIR.com, he's co-creator and administrator of the Digital Forensics Discord server, and he maintains dozens of GitHub repos with mind maps, KAPE targets and modules, and more. In other words, he's no stranger to forensics. The subject of this episode is based upon a series of articles that he and Josh Mitchell authored entitled Forensically Unpacking EventTranscript.db. Andrew will share his research regarding this newly discovered Windows forensic artifact, showing you why you should care and what you need to know to leverage it in your investigations. I hope you enjoy the content and welcome your feedback since this is the first episode of its kind. Thanks again to Andrew and Kroll for making this happen. Also, be sure to check out the links in the video's description for additional content and information regarding this research. So without further ado, I will hand it over to Andrew.
Hello everyone, my name is Andrew Rathbun. Welcome to this very special edition of 13 Cubed. I'm honored to be here. I'm very happy to collaborate with someone who I consider to be an authority in the field and someone who I just respect very much. So thank you very much, Richard, for having me here. I am honored to cover the EventTranscript.db, which is a new artifact that I found earlier this year when I was doing my everyday KAPE research for trying to find ways to make KAPE better. So pretty much the long and short of it is I was looking to make more maps for SQLECmd, and so I was looking for new SQLite databases, and I used the tool Everything. In case you've used it before, it's a phenomenal tool. Great replacement for Windows search. Strongly recommend you use it. Check it out. And I found using that, I found a DB file, a .db file that was 1 GB in size on my personal computer. So I decided to dive into it. And the resulting research that I did for the next few months ended up being all recorded in this article here. This series of blog posts on the Kroll website, Forensically Unpacking EventTranscript.db, an investigative series. Basically, this artifact is related to diagnostics and telemetry that Windows 10, starting with 1703, has been recording. So it's a pretty fascinating artifact. There's a lot of it that we do not know at this time. There are over 2,500 different events. It's insane how big this is. So we're going to cover a little bit of it here in this video, and I'm excited to dive in. But first of all, this series exists here, the Forensically Unpacking EventTranscript.db, and if you go to the bottom of this landing page, this is where you will see so far we have 10 articles out, and there will be more to come too as time goes on. Additionally, on my GitHub page, or on my GitHub profile, I should say, EventTranscript.db research. So I would strongly recommend going here. This is kind of where we're putting some of our, as we find it, putting it out to the community. There are, in this full event names folder, there is a list of all the different event names that we found for all these different categories. So there is some really cool stuff here to poke around and check out. The README here is really useful. So this repository combined with this blog post series here are really going to answer most of the questions that you have, so long as we actually know that information about this artifact. So without further ado, let's dive in. All right, so here we are in a fresh VM, a fresh install of Windows 10 20H2. The only thing I've done on this virtual machine here is install Everything, which is a very useful tool. So what we are going to do is I'm going to show you how to enable this database. We are going to start typing EventTranscript here. Okay, so we have EventTranscript, and we're going to do how basically I found out that we enable this. So diagnostic and feedback settings. Start typing diagnostics and you'll get this setting. You can see by default we have it to where the required diagnostic data is being sent. Let's go ahead and change that to optional. And then let's go ahead and do this, because this will enable a couple other things that are going to be logged. Tailored experiences, I don't think you really need to care about that, but this is really the main thing here is the view diagnostic data. Typically when you hit this button here, open diagnostic data viewer, that's when this database will pop up here. However, I don't think that this comes, well, here you go. Right when you hit open diagnostic data viewer, you can see that this showed up on the file system. But in order to view it, you're going to have to get this from the Windows Store. Now it's going to try and bug you to sign in and all that. You can just keep Xing out of this. You don't need to do this. So you can see we are installing it right now, and you can see our EventTranscript.db does now exist here in this path. Now if you try and navigate to this path here in File Explorer or any other File Explorer alternative, it is going to require administrative privileges. You're going to have that little access button that's going to pop up, and if you still have UAC enabled, you're going to need to work through that. So this database now exists. There's now information being logged to that database. So let's check out Diagnostic Data Viewer, which is basically the GUI front end of this database. Now this is what Diagnostic Data Viewer looks like. Now what's really cool here is you can go to the About Your Data and you can keep refreshing it, and you'll see this grow over time. And when I found this was a gigabyte for me. Massive database, lots of data. We'll dive into that here in a bit. But ultimately, what I found with this tool, it's actually really nice. All your WER reports, WER is WER, Windows Error Reporting reports will show up here. And all the live events on your system will show up here. Now, we do have the data currently is set to be at 1 gigabyte and 30 days storage capacity. You can change that from 128 to 10 gigabytes or 1 day to 180 days. You can also turn on Office Diagnostic Data Viewing, and then you can do Remote Diagnostic Data Viewing, which I've toyed around with this a little bit. Any of the Microsoft apps that you have on your phone, you can basically type in an IP address over a certain port, and then you theoretically can view them here in this Office Diagnostics section. I have not been able to get it to work yet, but I also have not spent enough time on it because I've been too busy with other parts of this database and exploring those further. So there's a couple other links around here. Learn more about Diagnostic Data Viewer where you can learn a little bit more about this. It's really interesting. As you can see, I just refreshed, and there's all these events that were logged just by us just really doing nothing. This is not going to have data sampling enabled. And the reason why I know this is because I'm not seeing sampling policies right here, right above the settings button. And also just some of the events, I'm used to seeing some of these events and associating them with whether or not data sampling is enabled or not. So in particular, this Win32K trace logging, again, really nice thing about this tool is you can filter very easily. I know that if you do have data sampling enabled, or at least a certain level of verbosity in the logging, you will see Win32K Tracelogging.app interactivity without the summary at the end. And basically you will see one of those events for every single time you bring up a new window. So I just brought up 2 different windows there. That would be 2 separate app interactivity summary events. And then now this would be another event, bringing that one into focus. This would be another event. This would be another event. So it's pretty incredible when you have that level of verbose logging, what it will log. And I will get into that. Here you can see 5 new events. I can hit refresh. Let's drop our filter here. So every single one of these event names, which is what is in this column here, is going to have a unique JSON payload. This is JSON format here. And the main difference is going to be in this data section of the JSON payload. Most of this above here is going to be pretty standard. It's going to have all these IDs, these make models, these just, you're going to see the same things over and over and over again. You can see there's not much change. But the main change here is in the data. So next, we're going to go look at my personal system that does have data sampling enabled, and we're going to see the difference in the amount of logging and just the different types of events that are logged. So we'll get into that. All right, so here we have a fresh install, a fresh VM of Windows 10 version 1607. And why this is significant is because EventTranscript.db did not exist at this point in time. Prior to EventTranscript.db, we had .rbs files. So I will quick demonstrate that EventTranscript does not exist on this system, which we're confirming that right now. But .rbs, if we filter on .rbs, you can see in C, program data, Microsoft Diagnosis, we have 4 different RBS files here. Ignore these link files. So here's the 4, and effectively what those consist of is the JSON payloads that we saw in the Diagnostic Data Viewer in the previous section of this video. So I kind of equate this as like these RBS files are like the .evt files, whereas EventTranscript.db is like .evtx. It's like the next step in the evolution of Windows telemetry and diagnostics. Change from this .rbs file extension to .db, which is a SQLite database. So a little bit different format, but logging mostly the same data. There's a really good write-up on these .rbs files, and I'm sure it'll be linked in this video. If not, it's linked on the Kroll website as well as the EventTranscript.db research GitHub repository. So next we will look at a data sampling version. For this next section, we are on my own personal computer because this is where I originally found this artifact. So this is, let me make this go away here real quick. This is Diagnostic Data Viewer on my personal system. I will show you the size of the database on my personal system once this populates here. But already you should be able to notice something different just by looking at Diagnostic Data Viewer. Here we have sampling policies, which is located right above the settings button, which I alluded to earlier. And now that this is populated, take a look at the data history size, 1.01 gig. That's a SQLite database that's that big. It's massive. You can see the oldest data point is 9/1/2021. You can see it's the 30th of September today. So it's pretty much a full month's worth of data. Look how many average events are sent per day, 60,000. We're on full, and then you can see problem reports created. So again, that's where you can see where all the WER reports are. Basically, anytime something crashes, it's all going to be right here. So and you can click on each one of these, you can see the contents of those. So some other stuff here, nice little graph. Most of them are going to be product and service performance. If we click on sampling, data sampling, or sampling policies, excuse me, you can read this little blurb here about diagnostic data sampling. Feel free to pause the video to read that. But when you go to settings here, you'll see I'm at 1 gig and 30 days. I do have the Office diagnostic data viewing on, and you can see if you were to connect your mobile device to this diagnostic data viewer instance, this would be where you set those settings up. So going to diagnostic data, I will demonstrate the verbosity here. Look at these little icons. These icons did not exist in the previous portion of the video. So that means, or at least we believe, that these are events. Real quick, I got to interrupt myself. Look at that, 525 new events just showed up. And I can click here to refresh. But basically, the verbosity is so high on my system, there's so many events per second. Each of these are related to data sampling. At least that's what we believe, especially considering it says view sampling policies here. So one of the most interesting ones that we found is going to be the Win32K Tracelogging.app interactivity, which I alluded to earlier. So again, the unique JSON payload is going to be pretty much this data section here. Now, I'm going to do a live demo right now of bringing up a couple applications up to the topmost of my screen here, and we're going to see what is logged. So EditPad Pro I have here. Okay, we got it open for a couple seconds. Let's go Sublime Text. All right, let's open that. And I believe I also have, yep, let's open up Timeline Explorer. We'll just sit on that for a couple seconds. And then Calculator. And then let's go back to Diagnostic Data Viewer. Okay, so what we're going to do is we're going to refresh this. And so now what you should be able to see is you can see the time is 23:45. So you can see all these events that were just recorded within the last, really the same minute. So it looks like the first one was on the 11th second. And so you can see Edit Pad Pro. Go to the next one, Edit Pad Pro, Sublime Text, right? That's the order we did things, basically. Sublime Text again, and then Explorer. And I'm assuming that is maybe when I was doing my Alt Tab. And then Timeline Explorer, oops, Timeline Explorer. And actually what you'll find here is this is the SHA right here, the SHA-1 value, which is good to know. And I believe, if I remember correctly, that is located up here as well. So there's actually two different locations where the SHA is located. Back to Explorer, Application Frame Host, Application Frame Host. Yep, Calculator app. Again, this is all going in the order that I demonstrated. I did of the demo basically. And what's interesting here is you can see a focus duration milliseconds. So if you convert that to seconds, you can basically figure out, how long did someone have calculator app.exe open. Now, in our testing, I work in incident response, so that's the angle that my research went. We did find, Josh Mitchell and we found that, for instance, size.exe, which is a piece of malware, it would execute, it would pop up just real quick and then go away, kind of like what a lot of malware does. And then so you would see the focus duration, and then it would log the SHA-1 value, which is very valuable because then you can run that through VirusTotal or various other sites that do malware analysis in that regard. Very, very useful for incident response from an incident response standpoint. Also, it's just really fascinating. You can really lay out the pattern of life of someone if they do have this enabled and this level of verbosity in the logging. There's still some research that needs to be done exactly what application frame host.exe means, but you can tell that the general order of events was exactly what I just did. So in that time that I've been talking for the last minute or so, there were 1,400 new events. And now granted, they weren't related to this because we haven't changed screens yet. But one thing that I do want to demonstrate as well is that this app interactivity summary, if I were to close one of these, so let's go ahead. Okay, so we should have a new event, right, for bringing this up front. Now let's close it. Okay, we just closed it. So let's give it a couple seconds. 92 events. You can see it just jumped from 9 to 92. Let's click here. Now we have our app interactivity summary. So effectively, that is a bookend, the back end of an application was closed. So this is basically saying it effectively was closed. You can see, and again, a lot of research still needs to be done in a lot of this. The aggregation duration milliseconds. So this theoretically is how many milliseconds that application was open. I do know it is based off of since this time, which I haven't figured out yet why exactly this time is chosen. There's no pattern to it. I've seen it be a day ago. I've seen this be a week ago. I don't really know the logic behind that. The in focus duration milliseconds, how many times it lost count. I'd have to go back and watch this video, but that seems about correct. I'm assuming that means focus loss count means you basically brought something else on top of it. So I think that's about right. 2 times. I mean, look at how much is right here. Here's the width and height, the pixels. If that's true, this is a 1080p monitor. It's really incredible how much stuff is recorded about, such a simple event, just switching the focus of what window is on top. So from a forensic standpoint and a pattern of life standpoint, this is really valuable. Now, the main issue is we don't exactly know what causes this level of verbosity. Yeah, there are registry settings that you can do, but it seems like you can only do so much, like I demonstrated earlier in this video. to enable diagnostic data, optional, all the, I mean, the inking and typing, all that. You can only do so much. It almost seems like Microsoft has to do their part in this transaction and allow that level of verbosity because all these events are being sent to Microsoft. So from a forensic standpoint, that's great because, I mean, if 60,000 events being recorded per day on my personal system, you could look at that database and pretty much put together what is going on what I did on my device on my computer that day. So really fascinating. Lots of data. Again, we've seen with this data sampling here with all these blue icons here, we've seen over 2,500 different unique event names. And by unique event names, I mean this is a unique event name. This is a unique event name. This is a unique event name. Skipping one. This is a unique event name. 2,500 of those, each with their own unique JSON payload, which is typically right here in the data section. There is so much to dive into. There's so much to test. There's so much to figure out what could potentially be relevant. It's really overwhelming, quite frankly. But this is effectively, this is what we have so far. There's a few other events that we figured out that are useful. Kind of going off script here, but there's clipboard history, activity started. So when I copy something and then when I paste something, you will know that there is an event for that. And I can't remember exactly what it is. Copy action detected. I think that's it. Again, more research needs to be done on this. There's so many different events. There's so many things you could do on a Windows system with this level of verbosity enabled that are going to cause so many events, and then trying to figure out what exactly you did to cause a certain event, it's just going to take time, quite frankly. So we are seeing this artifact still on Windows 11. Nothing has changed, or at least from what we've seen so far. I think this artifact is going to exist, and if anything, I think this level of logging will either increase or maybe this will be the norm here in a few years. This type of data sampling. I don't know. I can only guess. So, but this I hope was a very helpful look into what the telemetry and diagnostics look like in Windows when it's enabled. Next, we will go into how to parse this database. Now, before we get into that, you can export this data and just save it out to a CSV. It's not the greatest. I much prefer parsing it with either SQLEcmd or using Abhiram Kumar's EventTranscriptParser, and those are two things that we will get into right after this. Well, before we dive into EventTranscriptParser and KAPE and SQLEcmd, I'd like to quick show everyone how you can take this database and throw it into a SQLite data viewer like Navicat. Navicat is what I use. It's really powerful in building queries, and yeah, I'll just do a demonstration of it. It's not a free product. It does have a 14-day trial that you can try out, and I would strongly recommend you look into that. So anyways, we're going to take this EventTranscript.db database here. We're going to drag it right into Navicat. You can see it already makes the connection to it, and to demonstrate that, close connection, double click on it. We've established a connection, double click, and we can see what tables and queries we have associated with this. So this is what the schema looks like for EventTranscript.db. You can see the event categories, categories, producers, events persisted, provider groups, tag descriptions, and event tags are the main tables here. So we will see all these right here. Now, what we could do is we can take the SQL query from the map that I made for this database. So our SQL query pretty much starts right here at the select. It's everything within this pipe and all the way to the end. And there's a lot of this first part here is just me resolving SIDs. So just that's more for readability for the end user here. So from here all the way to the top, this is going to be a SQL query. So I'm going to copy this. Alternatively, you can turn on column mode and you can just grab all of this. and then you can copy it, and then we'll go to Navicat, and then we'll do a new query here. We'll paste here, and one of my favorite features of Navicat is Beautify SQL, and so that kind of prettifies it a little bit. Beautify. So what we're going to do is we're going to run this, and of course we would have a syntax error because I included the pipe. And that's how live demos work. So we'll do Beautify again, and we will do run. And so this should be running here. It took 2.2 seconds, and we have you know, the user ID, the timestamp, the locale, the tag name, the full event name. So that's what we have, 25 plus unique values that we found so far. The binary name, the friendly logging binary name. We also have the full event name hash, keywords, group GUID, is core. My best guess on that is it a Windows Core application, but I very well could be wrong there. Again, more research needs to be conducted on this. The compressed payload size is right here, and then the actual JSON payload itself is going to be right here. So this is what the output is going to look like when we're running these queries in SQLEcmd, and then we'll put that into Timeline Explorer. But this is a way where you can toy around with these queries using the query builder, which is a very nice visual of what is going on here, what table or what columns are being chosen from which tables, and then which joins are active to effectively dedupe the output or link together like columns. So it's very cool. I went into using Navicat not knowing anything about SQL, and just by using this query builder and just toying around with it, I was able to learn it. I have a working knowledge of it, I should say. I'm not a genius with it by any stretch, but this is super helpful. And then you can build and run your queries. If you don't like how my query is, if you don't like this being called locale name, you could call it something else, literally, if you wanted to. And then you can run it, and then you will see that column is now going to be called something else right here. So it's pretty cool. This is how you can make your own queries. So this little section of this video kind of serves a double purpose, how you can do your own SQL queries, as well as how to effectively validate the queries that other people write. So now we will move on to EventTranscriptParser and SQLEcmd using KAPE. The first tool that we're going to look at is EventTranscriptParser by Abhiram Kumar, who is well known for his work with the MemLabs GitHub repo, which is a CTF for memory forensics. Highly recommend you check that out. Abhiram does great work with that. So he created this parser with Python. I am by no means an expert with Python, so he actually helped me get this one running. So I'm going to show you what little I know, and we will see what the output looks like. But he's done a great job with this. So here we have PowerShell. This is where I downloaded the script, installed Python, made sure to have Python install the environmental variable. So we're going to go ahead and do our EventTranscriptParser.py. And we're going to point to where our EventTranscript.db file is, which I made a nice DB directory here. And we're going to right-click, copy the full path name, put that here, and then -O for the output. And you know what? We're actually going to just put it in the same folder here. So, and then all we got to do is hit enter, and then we should have output. So you can see it outputs some CSVs, it outputs some TXT files, you know, physical disk info, user defaults, and a couple other things that can be found in the database. So let's go check it out real quick. I actually already ran this, and I know that only these 4 files here are going to have any information. The rest of these are just headers. So we're just going to take a look at these ones here. So when we open these two, let's throw them in Timeline Explorer. So you can basically see here a software inventory of this effectively is my personal computer at the time of this database being acquired, which was back in, I think, April of this year. So you can see software that I had, I think it was on this date, 4/23 here. You can see software that I had installed on my computer at this time. You can see the SID, you can see the name of the program, the install path, the install date, the program version, and the OS version at the time of install. So the other thing that we see here is plug and play device install. So you can see devices that were plugged in at some point in time or other system components. So this is very useful information. It's almost like a portion of the AM cache is duplicated within this output here. So I know there's more to come with this parser. Let's check out the user defaults here real quick. We'll open that up in EditPad. So you can see here what my default browser is, default for JPEGs, .movs, mail to links. And then if we go to physical disk info, this is where you're going to see with the serial numbers, the size and bytes of the drives, the partitions, the bytes per sector, and what type of media it is. So whether it's an SSD or a hard disk drive. So pretty cool information. There, like I've said before, there is a ton of information within this database. There's so much more that can be parsed from this. It's just a matter of diving into the 2,500 plus events and figuring out what is relevant, and that's just going to take time. And as the community builds this out, these parsers are going to be a lot more valuable. So really great work, great initiative on Abhiram's part. Highly recommend you go check this parser out. And next we are going to go look at KAPE and how we can leverage SQLECmd and parse this database with the map for EventTranscript.db. Well, before we move on to the next section, I wanted to take a second to demonstrate EventTranscriptParser one more time with a better database, a database that has more data that'll show the output that EventTranscriptParser by Abhiram Kumar is actually capable of. So what I'm going to do is I'm going to open up a PowerShell prompt here, and then I put a command here that I typed right before I started recording this video here. So we got our EventTranscriptParser.py pointing to this DB that Abhiram provided me, and then we're going to output into the same folder where that DB resides. So when we hit enter here, we'll see it pop up, and you can see all the CSV output. So we are then going to open up Timeline Explorer. As you can see here, we have physical disk info and user defaults from earlier, and we also have a couple, five populated CSVs it looks like. So we'll throw these in here. And you can see that we have browser history, and we have software inventory, a WLAN scan. So we did not see this in the previous section where I covered this tool because I was using a desktop. I don't think that has ever connected to Wi-Fi. This clearly is a database from a laptop, something that uses Wi-Fi, I should say, because I suppose you could set up a desktop to use Wi-Fi. So we have our plug and play device install here, and then Wi-Fi connected events. So you can see some of the other information that is recorded within this database. So like I said before, I know a lot more is to come with this parser, but I wanted to demonstrate this because, and this database is actually from a CTF. So if I remember correctly, the scenario is that browsing history has to be recovered from this database, and you can see that it most definitely is recorded here. And it looks very similar to some of the other browsing history output that I use in a day-to-day basis. So pretty cool to see that. So anyways, we'll get on to the next section now. All right, now we're going to dive into KAPE. We are going to use just the module side of KAPE to parse this directory where we know we have our EventTranscript.db database residing. So we are going to go ahead and grab this file path here, and we have GKAPE up here, the GUI of KAPE. So we're going to enable the module side, and our source, which is where our files that we want to parse, where they're residing, is this directory. And frankly, I'm just going to have where the parsed output, I'm going to have it go into the same directory. The way that this module works is and it's the SQLEcmd one that we're going to run, is whatever is put here for the category, it's going to create a folder named SQL databases, and that's where my CSVs are going to reside. So I'm going to go ahead and select this module. So I'm going to be running the SQLEcmd module against this directory, which is where that database resides. We're going to do CSV as our export format, and we're going to have debug messages on just because that's the way I roll. And in terms of the actual maps that are going to be ran, I have them up here in EditPad Pro. So these are identical, the only, except for one or two things, no data sampling and data sampling. So if you keep going back here and you look on this line here, the identify value, you go back and forth, you can see there's 4 and 7, 4 and 7. So I have found in my research that when there is no data sampling, these tables here, there's only going to be 4 of them. So I'm basically saying, hey, SQLEcmd, look for all these tables, and all I need you to do is match 4 of them, and then run. If that is met, if that criteria is met, run these queries below here. So for this one, data sampling, I have found when data sampling is enabled, all 7 tables exist. So that's why I put the identify value as 7. So that means your output is going to say, you know, it's for browsing history, for instance, it's going to, your CSV is going to start out with EventTranscript, or excuse me, it's going to be Windows, and then here at the bottom, it'll be EventTranscript.db underscore browsing history underscore data sampling. So this is going to be your indicator right here that data sampling was enabled based on the research that I've done so far to show that when all 7 of these tables exist, it's an indication of data sampling. So we are going to run it. I know that this database does have data sampling enabled, so I would expect to see Windows underscore EventTranscript.db underscore insert tag description here underscore data sampling. So let's see if that's how it works out. So we're going to execute this, and it's going to execute the map that fits the database. So you can see it's looking for files here. It found map queries, found 6. So that means there's 6 queries in that map file that I just showed you. And you can see it's dumping a CSV for, you know, browsing history, device connectivity, inking and typing, product and service performance. And if we look here, we can see our SQL databases folder has been created, and we can see all this output. You know, we got a 604 megabyte CSV. We got an 83 megabyte, 4.79 megabyte. Let's go back here. Okay, so in 38 seconds here, we have a gigabyte database was parsed. So now what we can do is we can take these 5 CSVs and put them in Timeline Explorer. So there's only 5 CSVs here. That's because the 6 category there was no data that existed for that. So off the top of my head, it looks like it could be inking and typing. I'm not seeing inking and typing there, so that means on this particular database, which I believe is one from April of this year, 2021, there was no inking and typing data for it to parse. So we're throwing this in Timeline Explorer. You can see it's loading pretty quickly considering it's 906 megabytes of databases or of CSV output. Really can't be mad about that. So we have all 5 of them here loaded up. Now what we can do is if we want to look at browsing history data or any of the device connectivity and configuration data or product and service performance, we can all those are separated out by category. So Control R is going to reset the column width so they're all equal here in Timeline Explorer. The full event name is really what you're going to want to pay attention to. If you click up here in this column header, you're going to see a deduplicated list of everything that is in that column. And one of the things that I do all the time is you can see I have the edge of this column here all the way to the right. If I go like this, I'm going to have the little grabber thing here in the corner like this. And so I can drag it out to the left and I can make it taller and wider so I can then see everything that's here. And this is how I can get a really good high-level overview of what is in this column. So another thing that I do very frequently too is if I do Control-Shift-A, I'll be able to select all the contents, and then I have right-click enabled to copy. And so what I'll do with that very often is I will paste here in something like EditPad. I'll then sort alphabetically, which then it'll sort it. And we're looking at 250,000 lines here at least. So it'll take a second. And then you can delete duplicate lines. So I do that very often so I can see, this is actually how I update the GitHub repo is, what full event names exist for a particular tag description. So this is exactly how I do it. Sort it, delete duplicate lines, and then I'm able to get an idea of what types of events exist. And there's some interesting stuff here. Microsoft Windows Data Package .clipboard memory. There's just so many fascinating, here's prefetch. Here's mention of prefetch. These just need to be dove into and figured out what they are, what kind of value they can provide. Clipboard history service add item activity. That's indicative of doing a Control-C, So here we'll go delete duplicate lines, hit OK. And then if we go Control-End, go all the way to the bottom, you can see just in this database here, I have 1,526 unique full event names. So I said there's 2,500 that I've come across. Well, right here is 1,500 at least. So pretty cool stuff. So just within this particular one, the product and service performance, we have 1,500 unique events, and each of them have their own JSON payload here, which you can double click on this, hit the format button, and you have your formatted JSON, and you're able to see everything that's going on here. You can also use the filter, right now I have it on filter. You can use filtering to, hey, I did something on my computer. I specifically did it with EditPad Pro. That's where you can search, EditPad Pro, hit OK, and then you're going to find all the events that have a hit on EditPad Pro. And so from here, then you'll be able to see, okay, just these ones have EditPad Pro. And then that's how you can kind of learn, okay, SRUM, telemetry, app timelines. Maybe EditPad Pro is checking for an update. I don't know. That's just a total guess. But, as a forensicator, this is interesting enough to where, anyone should look at this and be like, wow, this looks really fascinating. There's a lot to dive in here, and it's very overwhelming, quite frankly. So, but this is the hardest part, is getting people to understand how you get to this point to where you can actually analyze it. I actually think the hardest part is getting this database to exist in the first place, but once you get there and you start populating data, that's where you can really start diving in and figuring out, okay, what does this database, what hidden treasures are still in it that we haven't found yet? And I know there's a lot of them. So hopefully this is helpful to give you, to kind of put a face to the name of what this database is, what it does, what it possibly could contain down the road. Stay tuned to some of the quick wins that we will keep producing on the Kroll blog as well as on the GitHub repo. If you do research yourself and you find new things, please look at that GitHub repo, do a pull request. If you don't know how to do that, get with me. I will teach you. That's a very valuable skill because a lot of the DFIR community is all about, it's all on GitHub, and it's all about the community coming together and aggregating our knowledge, because I'm not seeing what you're seeing on the case. I work different cases than what you work. I'm private sector. I work different cases from law enforcement. So all of us putting our knowledge together and centralizing it on something like GitHub on a repo, that's how we're just going to keep moving the ball forward in terms of research. So I strongly believe that, and that's why the repo exists. So I would appreciate if anyone could contribute any research that they have for this. So that will about do it for our dive into EventTranscript.db. If anyone has any questions, please feel free to ping me either on Discord or on LinkedIn or on Twitter. More than happy to have a discussion about this, and any continued research that occurs, we will make sure to put it either on the Kroll blog or my GitHub repo. And yeah, thank you for your time. And again, thank you to 13Cube for allowing me to do this and share our research so far, and hopefully provide the community with a running start as to, okay, yep, this is what it looks like. I see where he left off. Let's try and fill in some of the many gaps that exist in understanding the full breadth of this database. So, and with that, take care, be safe, and hopefully we'll see you guys around.